Hello. Today I want to show something that I built using JetStream. It's not really designed for this particular purpose, but it turns out a little bit of out-of-the-box thinking. You can solve some really interesting problems with JetStream. I will have this video and two other ones in the coming days of exactly such videos around problems we solved by thinking about JetStream, not just about streams. Today I wanted to build a tool that can limit concurrent executions of network-based or network-wide processes. So for instance, I have many machines. On every one of those machines I need to run a cron job. These cron jobs communicate with a shared database. Unfortunately, I have many more machines than the database resources allow concurrent requests for, and so we have to limit how many of these machines would hit the database at the same time. This is quite difficult, and often what people do is they just kind of randomly spread out the invocations across an hour, hoping on the law of averages or random numbers that says, you know, on average we're not going to be hitting a database more times than we can control it, than we've provisioned resources for. That's not very elegant, and it doesn't really work at a large enough scale. So in the new CLI, which will support NATS 2.3.1, which should be out soon, we've added a new subcommand called governor. And governor governs the concurrency of processes. The way this is done is by creating a stack that's limited to a certain size. And so, for instance, if I have 1,000 machines, I want to run 100 at the same time, I create a stack that's 100 maximum high. As a machine starts a process, he adds himself to the stack, and if it succeeds, he can do his work. By the time that the stack is full, new messages will be rejected, and those workers have to wait until one of the workers who finishes remove themselves from the stack, and then there's a space for the next one to go in. This way, you create a capped stack, and the network as a whole, or even as a supercluster, controls their access in and out of the stack to create concurrency. Let's have a look at how that works. NATS governor add cron. We want to limit 2 concurrent processes, and if the processes crash prior to finishing and prior to removing themselves from the stack, we have to have a bit of safety net in there in order to age them out over time. And so we're going to do 5 minutes. We've updated the one that was already there, and what you can see is we've got one called cron, limits of 2 and 5 minutes process time. What this does underneath cron is to create a stream that listens on a particular subject. It is set to limit retention, and it's set to discard new messages. And this will be the top of the stack. So if a new message comes in, it'll be discarded. We allow a maximum of 2 messages to go into the message before it's into the stream. Before it's full, at which point it will start rejecting messages. And we have a maximum age of 5 seconds to drop messages out of it if the worker is never finished. And that's about it. So let's have a quick look here. We can now view it and reset it, evict things from it, etc. Let's see. We can start one here. We'll go nats gov run in cron. We have to give it a name of ourselves so that you can identify individual entries in the stack uniquely. It's useful, it's not necessary. And the command we're going to run is just sleep 60. Well, let's make it sleep 30. Small typo. Okay. Now if we go nats gov view cron, we can see there's one entry on there, and my host name is in there, and I have an ID. I can evict that particular entry by just going governor evict and the ID, cron ID. I can purge the thing, I can completely reset it, etc. But depending on the size of your cron, you'll see, and how many current entries are on your governor, you'll see them listed there. Now the task is completed, and you'll see there's no active processes. That's about it. Now we have a terminal. I'm running the same command against my cron governor in all of these terminals, 16 terminals. I'm adjusting the interval a little bit down to 100 milliseconds. That's the frequency in which they're trying to put themselves into the bucket. You don't want to be too aggressive on this, if you have a very large network. But yeah, let's see. Small network. So 2 of them are running, and as soon as I finish, 2 more will run. If we view our cron, we can see them there, and we can do something like add cron limit of 5. Now we're updating our configuration. To 2 minutes, and we should see there's now 5 of them are concurrently running rather than previously 2. If we do this again, we'll see 5 of them are running, and as soon as they're done, 5 more will start. That's it. That's a little feature. Interesting little abuse of JetStream's core features and core behaviors to solve quite a difficult distributed systems problem. This will of course work against local clusters, local single node clusters, and superclusters. So you can run this kind of governed concurrency execution in your networks between San Francisco, New York, London, and everyone will continue to work. Really nice little use case. Thank you very much.